Hello. In this video, we'll discuss about domain and range of a function. As you know, what is domain? Domain is set of all possible input elements. And what is range? Yes, range is set of all corresponding output elements, right? Now here you see the word set of. The word set is very important to understand. What is a set? Set is a well-defined collection of objects. This is a very general definition of set. In mathematics, we normally consider these objects to be numbers. And these numbers are actually the elements which we are talking about. Okay, well defined. Well defined sets the rule which defines which elements will be as the input elements for our domain. So well defined is very important. That demarcates whether this element will be in our domain or not. Okay, so that's what well defined is. Normally, if we don't define our set, in that case, what is the default set? Default set for us is always x belongs to real numbers. Set of real numbers. Okay, this symbol here is belongs to. The Greek symbol epsilon. So x belongs to set of real numbers. I hope you remember real numbers. In short, real numbers, what are real numbers? So real numbers are all the numbers which could be represented on a number line. Okay, square root 2, pi, any number. All these numbers are real numbers. The numbers which cannot be represented on number line are complex numbers. Okay, for example, square root of a negative number, it is not real. Okay, so those are excluded, but all others which can be represented belongs to the set of real numbers. Just a recap, we have other sets like set of natural numbers. Natural numbers are numbers like 1, 2, 3 and so on. Sum of whole numbers. Whole numbers include 0 and natural numbers don't include 0. And then we have set of integers, right? Sometimes we represent by z, sometimes by I. So integers has plus and minus natural numbers. Plus and minus natural numbers, let me write, okay? And also 0, okay? So it's a superset of whole numbers and natural numbers. It includes both of them and also the negative numbers. Real numbers include fractions and square roots and all those things, correct? So these are our set of numbers which we will consider. Now, how to represent a domain? That is the next main question for us to answer, and then we'll get into detail how to write domain or range of a function. Okay. Now, domain can be written in many different forms. One of the most common form is the list form. So let me just write on first the ways in which we can write. One is list form. This is also called the roster form. And then we have interval notation. I'll talk about these just in a minute, okay? And lastly, we'll consider the set builder form. Now, list form. List form is normally used wherever you have a list, like tables, right? In tables, we have a list where x values are given corresponding to y values. This is better to write list form. For example, let's say we have this table where some x values are given and some y values are given, and let's say the x values are 0, 1, 2, 5, 7, and for 2, let's say the value is 6, and for 5 it is 7, for 9 it is 10. Let us say this table is given to us where this is defined by a function g, and x and y are so related that when you feed in 0 you get y as an output. In that case we can write domain in list form, and that's very simple. Just make these curly brackets. Curly brackets means set off, okay, and list all the values with comma. Inputs are 0, 2, 5 and 7, bracket close. So list of these x values becomes our domain. And what is the range? Range are the y values, and just list them with comma in between. 1, 6, 7, 10. 1, 6, 7, 10. Another place where list form should be used is set of ordered pairs. Now let me give you a set of ordered pairs. Let's say the set of ordered pairs here is 2, 5, 3, 2, 0, 5, minus 1, 6. Set of ordered pairs, they may not be in any particular order. Fine. Well, the x values are not repeating, so it represents a function. Okay. Well, you can write domain and range of a relation also, right? But we are at present just considering functions, trying to focus on functions. Anyway, now domain here is these x values. So we'll just list them as 2, 3, 0, minus 1. And the range is the y values. We'll list them 5, 2, 5, 5 we have already written, so we will not repeat it, okay? We should not write it again, and just 6. Of course, it is better when you make this kind of a list, put them in order. Well, it is advisable, you should, correct? Now here is a mapping diagram. Let's say in a mapping diagram we got these values. 1 is associated with 1, minus 1 is also associated with minus 1. The arrow shows the association in this direction. 2 with 4, 0 with 0. Now in this case, let's say this is our function f. In that case, we can write domain of this function as, so we'll try to list them in a particular order so that it looks nicer, okay? So minimum is minus 1, like minus 1, 0, 1 and 2. And the range here is 1, 4 and 0. So let's write them in order, 0, 1 and 4. Well, this is not wrong, okay? But this is better to write. So in such cases, we prefer to use list form, correct? Now I'll talk about interval notation. Interval notation is normally used when you have a continuous function where you want to represent sets in the form of real numbers, okay, where x belongs to real numbers. For example, let me just draw a graph here. Let's say this is R0, that's the fx, or you can say the y value, and here is our function. This is the x coordinate, okay? And let's say this is 1, minus 1. Let's say we have a function here which is kind of going like this, including this value. And then we have this function on this side, we'll say including this, and going parallel to this. This value is minus 2. This is 1 for us. Okay, now you can't list all these values in between. It's kind of impossible, right? You don't know what values are, right? So interval notation is very good for such situations. We could have used set builder form also, okay? Well, now let's see how to use interval notation to represent this kind of a function. In interval notation, we use brackets. You should know that we are assuming that here x belongs to real numbers. We don't really write that x belongs to real number, but it is taken as default, correct? In this, we include two types of brackets. This is the opening bracket which says start from here but do not include. This becomes a closing bracket, start from here but do not include. But in case if you want to include, then we should use these kinds of brackets. These brackets means start from here and include, okay? We can also have combinations of these. Well, there are no restrictions on that. Depending on our usage, we can use as required. In this particular function, you can see that this function extends to left from minus 1, correct? Minus 1, it goes left. How about the y values of the function? It is always minus 2. Let's consider domain first. We'll write domain here is equal to, it goes up to infinity. Can you ever reach infinity? No, we can't. So for infinity, we'll always use this bracket, okay? And it is approaching minus infinity. So minus infinity, and starts from minus 1. Minus 1. Is minus 1 included? No, it is not. That is a whole. Whole represents that it is not included. Now, our function starts, then there is a break in between, then starts again from 1 onwards. Point 1 is included, correct? So that included will be shown by a square bracket, right? Including 1 and then going forever. That means infinity, and you cannot go to infinity, correct? So the domain is union of both things. It includes both these x values falling in this region. So we can write union in between, okay? So this symbol U is union. At times we can also write comma, right? And then just say this and this, correct? So this is one way of writing it. This is interval notation, very convenient to write. Now let me write domain. Now domain is the y values. So what are the permitted y values for us? One is minus 2, okay? So write minus 2. And then what it is? It is from here to here. So you say there's one value minus 2 and then a region. In such cases, we'll prefer to use a set builder form. Okay, so next step is going to set builder form, but this is a good place to start. In set builder form, as I said, we'll represent it as a set, okay? Now here, x belongs to real numbers, rather y belongs to real numbers, since we are talking about the range, okay? And then we'll give condition, this is so that or such that, or where, what happens to y? Where y equals to minus 2, or what else? Or y is greater than or equal to 0. Bracket close. So this is a set builder form where we have used these brackets to indicate a set, and we have clearly specified that the range is a set of real numbers where y value is minus 2 and then y is greater than or equal to 0. Okay. So here we use combination of our interval and set builder form. We'll move forward and see some scatter plots and try to write their domain and range. Now, I'll just here some plot for you, very simple from the graph. As I told you, if there is a scatter plot, which is the best way of representing our domain and range? Well, list form is pretty good. So what is the domain here? Domain is the x values of these points. So x value of this point is 1, 2, 3, 4. This is 4, right? And this 3. This one 2. This one 1. All minus. And here it is 2. So the domain is set of numbers from minus 4, minus 3, minus 2, minus 1 and 2. Correct? And how about range? Range is the y values 1, 2. This is minus 2, correct? And here plus 2 for these, 3 for this and 4 for this. So range is minus 2, nothing on 1, 2, 3 and 4. Easy. So list form is pretty easy to write. And let's move on to another example. Here again, I have purposely given you a combination. Okay, somewhere it is continuous, somewhere it is not. Gaps in between. Remember, if there are gaps in between, good way to write it is in the set builder form or in interval notation. This is also a continuous graph, right? So x belongs to real numbers. So here we'll prefer to write in set builder form. So we'll say domain here is equal to x belongs to real numbers, so that, look here, this is minus 2, is it okay? Anything less than minus 2. So we say and minus 2 is included. So x is less than equal to minus 2, comma. Then we have from minus 1 to plus 1, but not including 1 and minus 1. So we have minus 1, x is greater than minus 1, but less than 1, okay, comma. And here this value is 1, 2, 3, 4, after 4. So x is greater than equal to 4. Correct? Yes. How about range? Range in this case can be given as everything from minus infinity to this place. So is y belongs to real numbers, so that y is less than equal to 2, this value is 2, or y is equal to this value of 4, or y is equal to this value of 5. So that is the way to give you range of this number, of this function. Okay. We'll take some more examples. Let us take equation. Okay. So we have already seen how to write domain and range for a function if it is given in the form of a table or ordered pair or mapping diagram or a scatter plot. Now let's consider some equation. Okay. Fine. Let's consider a situation where, let's take an example like this. Let's say sum of two natural numbers is 10. Now, how will you do this? What is the domain and what is the range? So, natural numbers, okay, 0 is not included, remember that. So, how will you get 10? Well, these are the combinations. You can have 1 plus 9, you can have 2 plus 8, 3 plus 7, 4 plus 6, 5 plus 5, 6 plus 4, 7 3, 8 2, and 9 1. Correct? So these combinations could give you set of natural numbers adding to 10. So of course the domain becomes these values. So that's the domain, okay? And what's the range? Range is these values. Do you get it? Yes, we do. Let us twist this problem a bit and let's remove the condition natural numbers. Okay. Now let's consider example where, let me change it in this form. This is sum of two positive numbers. Is 10. Now see, when we say sum of two positive numbers, then we mean that they are real numbers, and these real numbers are from, not negative, okay, because we have mentioned positive. So this situation can be written as x plus y equals to 10, where x and y are two real numbers. Okay, when we write an equation in this particular form, it is called implicit form. Let me write this word for you. From this equation, we can always write y equals to minus x plus 10. Now, if we can isolate y and write our equation in terms of y equals to something, then that becomes explicit form. Why am I touching on this point? It's kind of important. This point has been missed earlier. When we are talking about function notation, then we said that in an equation y can be changed with fx, right? If that equation represents a function. If it does not represent a function, you cannot replace y with fx. But you know what? It is not always very easy to explicitly write y as a function of x. Sometimes the values are so mixed up that we just can't do it. And if we can't do it, we'll not get explicit form, and then we can't write y as fx. Now, once I have written this in explicit form, I can write this as fx equals to minus x plus 10. I hope this extra bit which you learned today, you'll appreciate it in times to come. Now, y equals to minus x plus 10. What is this? This is kind of a straight line, but minus x plus 10, y-intercept is 10, and a line goes down like this. Is that okay? We are only considering a set of positive numbers, right? So in that case, what happens is that this is our set of positive numbers whose sum is 10. Okay? Now, this is 10 and this is also 10. You see? There could be many x values in between. If we add this x value and this y value, in general, x and y, we will get a sum of 10. So in this case, what is the domain? Now, domain here could be written in set form or interval notation. Okay? So we will write in short, whenever you get an opportunity like this and freedom, you should use the interval notation. Here the domain is from 0 to 10. Okay? So 0 to 10. I should say including both. Right? And how about range? Range is also from 0 to 10. Okay? These are the y values and this is x. 0 to 10. Do you see? When we changed our example from a set of natural numbers to positive real numbers, if I don't mention, it means what? Real numbers. Don't forget that. Always. If I don't mention, then it means real numbers. Okay? Set of real numbers. Correct. Now, We will see some more equations. Rather, today we'll close here with the last example of a circle. Let's say the equation of a circle, as you know, is x square plus y square equals to r square. Let's take radius of 5. In that case, x square plus y square is 25. Correct? Let's try to write this in explicit form. In that case, it becomes y square equals to minus x square plus 25, and y equals to plus and minus square root of minus x square plus 25. Since there are two values, we know it is not a function, right? Anyway, let's try to sketch it. If we sketch it, we get a circle. You know circle is not a function, right? It fails vertical line test. Here, this point will be minus 5. This will be plus 5. Plus 5, minus 5. Because the radius is 5. Is it okay? So, that's our circle. What is the domain and range here? Domain is x belongs to real numbers, where x is between minus 5 and plus 5. We could have written in interval notation also. Well, let me write this in set builder form. And range is y. Y belongs to real numbers, where the value of y is between minus 5 and plus 5. Okay? It is not a function, but we can always write its domain and range. It does have a domain range. It's a relation. Okay? So, today we learned about some very basic, simple cases, and we have understood that we can write domain and range in 3 different forms. One of them is list form, the other one interval notation, set builder form. You can also mix and match as per your convenience. List form is very good in case you are considering sets in the form of tables, ordered pairs, mapping diagrams, or scatter plots. Interval form and the set builder form is normally used for equations and graphs where the things are continuous. A continuous graph, because you can't really list all the real numbers in between 2 points. There are an infinite number of numbers between real numbers between any 2 points, so they can't be listed. So we have just the option of interval notation or a set builder form. Beauty of set builder form is that it's versatile. You see, we can always write set of what and include different kinds of conditions. As you have seen already, there are a lot of restrictions using interval notation. As you have seen, somewhere if something continuous comes and there is a break, it may be difficult for us to use interval notation. Okay. Now, word problems, we can write an equation. In case you can write an equation in the form of explicit form, you can always replace y as f of x, and then sketch the graph, get your function. Well, in the next video on domain and range, we will take scenarios for different algebraic equations, for example, polynomials, reciprocal equations, square root functions, the basic functions, and then see how we can write their domain and range. Okay? I hope you learned from here, and wait to see the next video where we'll discuss different kinds of algebraic equations. Okay? Thank you. Have a good day.